Shalom to you and welcome. In this video we're going to look at annuities and eventually we're going to look at stocks and bonds, but today we're just looking at annuities generally. Annuities are like savings. Okay, our objective is to determine the annuity and then the regular annuity payment. We have previously solved for annuities, simple annuities. So it's like how much money for the number 2 determine regular annuity payment needed to achieve a final goal. So how much which is the one you're going to use more often, because you want to know how much you can deposit to achieve certain amount of money when you retire. Okay, because that's it. So we're going to quickly on annuities. There are a series of payments made at equal intervals, so you can pay them every month or every year, or or every 2 months, every 6 months. So it's paid at equal interval. It has to be specific equal intervals. So example would be like the mortgage payment when you buy a house, or your monthly insurance payment, pension. So annuities can be classified based on how frequent the payments are made, This is an acronym that comes often, you see often when we talk about annuity, IRA. So it's individual retirement account. So individual retirement account, so it is an example of annuity, so which is a retirement that I think I have that definition on the next slide. So a company, in the United States we have that as is a form of individual retirement plan provided by financial institutions. They provide tax advantages for retirement savings. So, and there are different kinds of it. Some have risk, some have low, moderate, or high risk, and that will also determine the gain you're going to get. So yeah, you can check them out if you want, but just be aware there are different kinds and try to understand them before you choose. So, but we are concerned with just the ordinary annuities and do annuities to save money. The ordinary annuity and annuity they are basically the same thing, except that for ordinary annuity the money is paid at the end of the period, whereas for annuity it is paid at the beginning of the period. So that's all. And alright, so we're going to look at the problem. How much should you deposit at the end of each month into an IRA that pays 8.5% compounded monthly to have 4 million when you retire in 45 years? Okay, so this is the plan. I'm going to retire in 45 years, and after retirement I would like to have 4 million in my account. So that will determine how much do I need to put in, okay, and then how much interest will I get out of it. And I'm going to switch to document camera because I want to show you how to plug in the numbers inside your calculator to make it easier and faster. Okay. Alright, this is the problem, and here we have the annuity formula. The annuity formula. A is the final amount, P is the initial amount, which is the principal, R is the rate, the interest rate, N is the number of times the money is deposited. So, but this looks complicated. It is helpful if you solve for P first. Okay, if we solve for P first, since the initial amount is what we are looking for. If we are looking for the final amount, then we can easily substitute all the variables here and solve. But we are looking for the principal. So it's better to solve it before plugging in the numbers. Okay, let's do the algebra. So if we have a fraction, the first thing we can do is get rid of the fraction by multiplying both sides by the denominator. Multiply every term by denominator. If we multiply by this denominator, r divided by n, multiply both sides, that would be a times r over n equals p, then 1 plus r over n. We write everything else. This will only get rid of the parentheses and nothing more. Okay, so now the fraction is out, because if you multiply this on this side, it's going to cross out. Now next we are going to isolate p. We are going to get p by itself. So we are going to divide both sides by this whole bunch, this whole parenthesis. So if we do that, we are going to get a r over n over 1, can put that into parentheses, this whole bunch here, 1 plus r over n and t minus 1. Okay, so we have two parentheses there. So this part is on top, a times this fraction. So this equals p now. So because we divide this side, it's going to cross out. So we have p left on this side, and this side we divide by. So this will be the formula. So when you are finding, you can write it down, have it. When you are looking for a principal, you just use this formula, and when you're looking for the annuity, you use this one. So because we are looking for the principal, we are going to use this formula. It makes it easier. We have already solved that. Solve for p. So again, it's very helpful to write out all the numbers. Write out all the numbers, what each stands in the formula. So like we know P we are looking for. So we know the A is the final amount, which is 4 million. We want to have $4 million. So we have 4,000,000. And then we also know the rate. The rate is 8.5%. So the R is 8.5%, which is going to be, change it to decimal. So we divide this by 100, we get 0.085. Okay? And then the time, T, is going to be 45 years. Okay, it's 45 years. Okay, what else do we know? Yeah, that's it. We have everything we need in our formula. So we are going to, P we are looking for. So we're going to just plug things in. Okay, we're going to write the formula here. P equals A R over N all over 1 plus R over N and T. Okay, watch it here. There are two terms here. This one is by itself. So you want to make sure you simplify everything in here before, and then take the exponent before we subtract. So let's plug in the numbers now. So the final amount is 4 million. Make sure you get the number of zeros. 0, and the R is 0.085 over. Now, annu is the number of years. I mean, the number of times it is compounded. How many times? It says every month. So how many days how many times in a year? How many months in a year? There will be 12. So it's going to be compounded 12 times. So n is 12. So over 12 all over, and then we have here 1 plus, again, 0.085 over 12. Then n is 12 times t, which is 45, and then minus 1. Okay, And just the way it is, if you have a graphing calculator, you can plug everything in as it is, and the calculator will do it for you. Okay, so let's do that. Okay, here. And if you don't have a graphing calculator, you can also use GeoGebra, or then you can do it manually. Okay, let's plug it. But you have to be very careful how you plug that in, because if you miss any one thing wrong, it will make everything wrong. Okay, so I'm going to use my fraction formula here. So it's gonna be the alpha y. So alpha y, and then select the fraction. Okay, and then we have on top, we have 4 million. 4, 1, 2, 3, 4, 5, 6. There were 6 zeros. And then we use times the multiplication. Okay, move this out for now, so it's not on the way. Okay, so you can see the calculator there. Okay, so times multiplication times. Okay, and then we're going to use another fraction here. Okay, and then we put 0.085, and then we're going to use the arrow key to bring our cursor down. We put 12, and then we use that cursor again to come up. Now we are done with the numerator, so we're going to use this cursor again to come down. And then below we have parentheses, so we're going to put that parentheses in the parentheses. And then we type 1 plus, and then we're going to put a fraction, again alpha y. So again 0.085, and then we're going to use our arrow to come down over 12. We're going to use our arrow to go up, and then the parenthesis is closed, so we close the parenthesis. Press the parenthesis close. Then we have an exponent, so we're going to use this arrow to go up to put the exponent, just 12 times 45 again. So if you have a good calculator like that, you don't need to simplify anything, just plug them all in. So this is the cursor come down for the denominator. So there is one more there, minus 1. That's when to put that in, minus 1, because it is still in the denominator. Okay, so our denominator is done, so we're going to use our cursor and go back up. So everything is plugged in, hit enter. 640.75. Okay, we're going to round, because it doesn't make sense to put, that sense at the beginning. I hope you can, it makes sense to put a whole bunk of money. Okay, so it's good. The P is going to be, it says 640.75. So which we are going to round to $641. So this is the amount that you must deposit in the account and then to be able to, and then you'll be paying that amount every month. At the end of every month you deposit $641. At the end of every month you deposit $641 to be able to get that 4 million at the end of 45 years. All right. Now, it says how much is the interest. So of all the money, so what we're going to do to find the interest, this is the money you'll be depositing every month. So to find how much interest is there out of the 4 million, we're going to multiply how much did we deposit altogether. So how much did we deposit? So we can just use, since it is every month, so 12 months in a year. So we have 12 months in a year. So every year, okay, 1 year, we are going to deposit how much? We're going to deposit 12 times 641. So that's how much we're going to deposit in a whole year, in 12 months. So 12 times 641, and that gives us 7692. So every year, the total money you deposit, because the money you deposit is constant, which is the 641, And then for 45 years, how much would you deposit? So we're going to do for 45 years, okay, for 45 years, then we're going to deposit how many months? Do not multiply 45. How many months in 45? So we already have the years. We can just multiply 45 by 7692. So, but if you want to do it in year, you have to get the number of years in 45 years first. Okay, so it's gonna be that times 45. So because I still have it in my calculator, I can do answer times 45, and then I get 346,140. Okay, so 346. So in 45 years, you must have deposited 346,140. Okay, I hope you understand this section. Again, every year, which is 12 months, which is 12 times, because you are depositing every month. So you deposit 641. Because a whole year you deposit this amount. And so in 45 years, you're going to deposit whatever you deposit every year times 45 to get this amount. So how much interest is there? So we're going to find the interest then. The interest is always the final amount, which is 8, minus the principal, the initial amount. So the final amount is 4 million. Minus the principal, which is, I will say, the total money now you invested, 6140. So since we already have it in our calculator, we can just type in the 123, 4 million minus, we can select it, okay, using our arrow, and hit enter again. 365, let's see right here, 365, here 365, 3860. Okay, and put the commas. Wow, you earned interest of 3,653,860. Wow, that's a great investment. Very great investment here. So when you deposited only this amount, you did only 346 you deposited, and then you gain this because it's fixed. All right, good investment.